thought that it was finally time to introduce an end-to-end test suite that does acceptance tests for our extension. We're going to see one, the UI that we use to go and run the tests. Two, we're going to see a little toy website that we built that allows us to go and like really drill into these tests. And three, we're going to see some of the code that runs it, so we can explore any of the above as the conversation continues.
Let's do it.
Yeah, so you wanted to chat about some of the tools that I've been building around the end-to-end testing, right? And one thing about us as a team, and something that I really enjoy, is that we have a team of manual QA testers. Mark, Tim, they're like heckin' amazing. It's their job to like go and try and break jam as much as possible before it goes out to users, because users, the internet is chaos, and there is all sorts of different ways and scenarios that people end up using us in, and having some folks on the team whose job it is to like flex what we build to minimize surprises to users is always really important. But part of flexing the extension is also making sure that we don't break behavior on all of these different websites. And it's really difficult for part of our regression testing analysis for manual QA testers is to like go to all of these different websites that may or may not be behaving similarly as to the time that we discovered that we were doing something that would break a fundamental expectation on the site. And so for that reason, we thought that it was finally time to introduce an end-to-end test suite that does acceptance tests for our extension. And since QA is really good about testing our core flows, we thought that we would prioritize the web compatibility tests and make sure that we are building an extension that is a good citizen on the web as people use it. So that's kind of the like why now, or some of the before cases that we ended up needing to solve for.
Oh, well, I want to see the test now.
Yeah. Oh gosh. Sure. I can open up the little test suite UI. So here is the UI for our tests. We have these web compat tests that we're running. We don't really care about example. We don't really care about events right now. And we have these like fetch scenarios and XHR scenarios, and we are using kind of the same structure for both of these. We want to see that like if the fetch throws, if the fetch has request or response bodies, or doesn't have request or response bodies, when it does have request or response bodies, we want to go and see, oh, the request is plain text data. The request is a URL, like a data URL. We're streaming plain text data. We're streaming data URLs. And each one of these is also, again, the same kind of stuff inside it. Do we handle different types of status codes? So like 201 created, 301 redirect, 400 is an error case, 403 is a forbidden, 500 is a server error. When the client aborts, sometimes we could get the abort happening before the response is received. Sometimes we can get the abort happening after the response is received. And we want to make sure that we're handling all of these cases correctly.
Are there any of the cases that are more difficult than others, or that were like particularly like a pain to set up, or would you actually consider them all sort of equivalent?
I'd consider them all pretty straightforward. Like the challenge is more that because there's all of this branching behavior, that internet is chaos, and so there's all sorts of different scenarios that can exist, and we obviously cannot test them all exhaustively, but we do want to be able to test as many of them as possible. And so looking through the code that we've written and the code that the extension is running to identify all of the different branches that it runs, and then figure out the different behavior that we want to test. So like, we make some manipulations on the CSS style to like CSS style sheets and CSS grouping rules and adopted style sheets. We want to go and make sure that, when someone uses set property or like a direct setter, that we are styling things, that the page styles things expectedly, that the adopted style sheets number is correct. And so we just need to go and make sure that we're handling all of these different behaviors. So like we can go and run the client aborts, and we can see that it rejects with an abort error. It creates a matching network event. This should succeed unless I may be in a state where, nope, my extension is in good health. So it goes and just kind of runs these for us. And so on many of these, not all of them yet, but on many of them, we've created these test pages so that a developer can go in and like see how things work. And so when we're testing the fetch requests, we can go and see that like, we want to create a request that throws. And so here's just a little run button. And the way that the test works is it checks, is the result the expected result? And we do expect it to reject here. And so in order to get this written, we wrote this code over here where let's go to server fetch and test that throws. We make a request and we kind of just have this component that says, here's a form that tests that something throws. And because we reuse this same component across both the fetch and the XHR, we just kind of say that here are some request parameters. We make a fetch request to the URL with this method and with these headers. And the fetch that throws is basically just trying to post an invalid header. And this should never, ever work. So we, if it for some reason succeeded, we go and set the result as resolved, but we actually expect it to catch and end up in this rejected state. So when we look at the tests for fetch plus XHR and we throws, when the mechanism itself throws, we check, we go to the webcompat/fetch or the webcompat/XHR page, webcompat/fetch. And then, if we wanted to go to webcompat/XHR, it's the same thing. And we go and we look for the data test throws button, and then we click it, and then we wait to see what the result is. And then we expect over here that it rejects with a type error. And so we look for the form data test throws, and we see that the data result for that form is rejected. And so matching this back, we expect that the data result here is rejected. Over here with a 204, we just expect that the response status is a 204. That's it. If we request that it will return us a 500, we have the function return us a 500, and we make sure that the response status is a 500. And so this one is just like server fetch. And again, form test no bodies. We go and provide some stuff, and then we inspect the response and say that the response status is the response status. And if we actually got a response body, then we would throw an error. And so over here in the make request, we can see that, let's jump actually to form test no bodies. And so this is using a framework called 10-stack start. And it's really handy because it allows us to go and define this form in our file. And so we have this thing that says on submit, we'll go and like make our request parameters, and then we take this make request that function that we had provided into the component, and we say, here is the URL we want to go and request, here's the method, here's the headers that we want to send, and here's the body. If this response is successful, then we want to go and set the response status as response.status, and if it rejects, we will set response status to reject it. And then the really cool thing here is that handle no bodies is literally in the same file. It's a server function that we create that expects a post, and then we go and effectively pass in the expected status through URL search parameters because we don't want to be sending a body here. And so if there's no status, then this function is going to throw an error. And otherwise, it just reflects the status that we requested right back at us. And so that's why when you go over here and you look at the network tab, this says it's a 500, but we wanted a 500 because you could see that we made the request to this handler status equals 500. And we sent it with the headers that we had expected. And then we received a empty response, which is what we expected. And so over here, if we say 204, this is going to give us a 204. And if we say 404, it's going to give us a 404. And over here, we can go and make our request with body. And so we might do a streaming body. We might do a plain text that, let's say we want it to be a 201 and we want it to be a success. And so we get a 201. And again, our form communicates, the body that it received back, the response status that it received back. In a data URL scenario with a 403 and an abort late, we still get 403 and an echo hello world. And our test, as we saw before, knows that it aborted late. So it was really handy to be able to build this and, again, use this in a way where we can go and inspect the extension at any given point in our own browser. In here, I'm using Arc, but over in the test runner also has the extension installed, so we know that the extension is behaving correctly so long as the tests check out.
And I guess like what this would allow you to is like if we have a hypothesis about a certain like combination of these attributes that's causing the error, you could immediately go back and be able to pinpoint that rather than being like oh, I'm not sure where this error falls into the hierarchy of problems, right?
Even better than a hypothesis, Ian, is that we can run this test suite in our continuous integration. So when we have a pull request that's merging, when we cut a new staging release, we could say, because this can be an expensive test suite to run. So we'll probably start by, now that we have it mostly written, we're expecting to start putting it into our continuous integration and be part of our deployment process. And one of the ideas is that when we cut a new staging release, we're going to say, run the test suite. Tell us, did we make any very obvious expected breakage in this, so that we can go and fix it in the staging release before, like, Mark and Tim don't have to test it anymore to tell us about this. We just get an alert in Slack that says, there is a breakage here. Please go fix this web compatibility issue. And this will happen for us testing the extension exhaustively in all of these different scenarios that we're aware of.
Oh, that's awesome. I was gonna say, are there clear next steps with this, like future types of error, like where we're building this out still currently? Like, because what you showed, yeah, I'm curious.
Yeah, there's a number of suites that we have open, very similar to these guys. I'm gonna close them up. But similar to like Fetch, XHR, and WebSocket stuff, we have a number of other, and like CSS, we have a number of other core behavior, like core patches suites. We've decided that we are renaming this from WebCompat to like patched behaviors. And we have a number of other like patched behaviors suites that are very close to shipping. They'll probably be merged today. And then, as I mentioned, we need to put this into continuous integration so that it's not just running on developers' machines, but instead alerting the entire team if there's a regression in something that we're trying to push up to staging. And so that's a very obvious next step. Like some of the surprises or learnings were that there are these opportunities to make the product even better and more reliable for our users just by doing this analysis and getting real deep in the weeds. So finding some of those as a still relative noob on the team was a lot of fun.